I am here to talk to you all about PointsBet's journey to Observability 2.0, but more importantly, being able to break vendor lock-in with OpenTelemetry and also making observability a first-class citizen within our org. So, quick introduction. Who am I? What do I do? Why am I here? My name's Adam. I'm a staff site reliability engineer here at PointsBet, and I have been at PointsBet for about 5.5 years. I am part of the infrastructure team. Infrastructure team is that similar to a platform team. You may have guessed it. We own the shared infrastructure, shared internal tooling, and we are really an enabling team. We not only are there to empower the developers or the delivery teams to ship code to production, but we're here to empower them to ship code confidently and reliably as well. I, of course, specialize more on the observability and reliability front, hence the SRE title. And here at PointsBet, we are a very heavy Azure-oriented tech stack. Majority of our services are .NET applications, and majority of these as well are hosted in the Azure Kubernetes service. We do have a few Rust applications running around there in the wild as well, and we do have a small subset of our applications running on the PaaS ecosystem, so things like app service plans, container apps, etc. So who are we at PointsBet? What do we do? Well, PointsBet is part of the wagering industry. We are an online gambling product. We offer this product to our customers. We operate nationwide in Australia, and we also operate in Ontario, Canada. In both Australia and Canada, we have a sportsbook offering. Specifically to Australia, we have a racing offering, Spring Racing Carnival, busiest period for us. And in Ontario, Canada as well, we have an online casino product as well. So why is observability important to us? Well, you can make a comparison of a wagering platform to that of a trading platform. It is a very fast-paced, high-octane environment, especially during an incident. When you are in an incident, moments matter. Every second counts. The longer your system takes to detect there is an issue, the longer that you take to triage and apply mediation for that issue, impact grows exponentially. Okay, not only from a revenue impact point of view, but also from a customer branding point of view as well. There are plenty of competitors out there. Your customers will simply go and use one of those if you cannot provide a reliable system for your end users. So, I want to paint a little bit of a mental image over here. It's 2 a.m., you receive an alert, you're cold, it's dark, it's gloomy, and this is what your desktop might look like. This is what your desktop will look like, or what mine looked like, before I've even found a single answer, before I've even started to triage. So you can see here we've got Jira for our incident management tool. We've got PagerDuty as well for our alerting and paging. We've got Application Insights here for our app monitoring data. We've got Datadog for our infrastructure monitoring. And we've also got our Azure Managed Grafana instance because why not? More dashboards are better. At the end of the day here, you're not just debugging your system, but you're also debugging your tools. Multiple sources of truth, multiple entry points. Cool. So the cracks that we identified that we as an organization needed to patch. Well, first of all, we had that scattered tooling. Telemetry split across Application Insights, Datadog, Azure Managed Grafana dashboards. We were locked in, our telemetry was not only tied to our application, but it's also being tied to the vendor. We had blind spots, no RUM, no profiling, no SLOs, PagerDuty and Jira bolted on the side of this. And we had obscure costing as well. Multiple bills, multiple tools, no clear attribution. Couldn't identify which team, which signal, which service was driving this. So why did we decide to version it? Well, I first heard Observability 2.0 probably about a year and a half ago. I think it was by Charity Majors. And what was being said about Observability 1.0 was extremely relatable to us. We really resonated with it, and this is what our kind of current environment and platform was like. We had many sources of truth. We had siloed tooling. We often were debugging by intuition. Often or not, I'm sure every org has that kind of Oracle triage engineer that's just been part of so many incidences that he's just a gun at triaging. We had obscure costing, but importantly, observability was always an ops afterthought. That's something that we wanted to change. Going over to Observability 2.0, we wanted that one platform. And with that one platform, we wanted that single pane of glass with all the context brought into it. Application, infrastructure, and business metrics. You notice I use the word context. Probably if I had done this 6 months ago, I would have used the word correlate, but just given the agentic world we're living in, I think context is a much more fitting term. We wanted that one protocol with OpenTelemetry. We wanted clear cost and attribution. But we also wanted observability that was shipping with the feature and shipping with the product. At the end of the day, for Observability 2.0, we didn't want to buy a tool for the applications. We wanted a platform for the entire operation: telemetry, alerting, costing, synthetics, incident response, profiling, whatever it might be. Cool. So why Grafana Cloud? Well, we did our due diligence. We did a POC on New Relic, Datadog. We even revisited our application insights setup, and Grafana Cloud just came on top. First of all, open by default. Open telemetry and Prometheus native. There was no proprietary agent, and the exit ramp for us always stayed open if we ever needed it. Cost became a feature, not a surprise. We're able to break down spending and attribute this to a service or a signal or a team. And also the use of adaptive telemetry gave us that transparent feedback loop. What are we using, what we're not using? We're able to bring in all that context in that single pane of glass to correlate everything: metrics, logs, traces, profiles. Now we're building one single story, not 4 different tabs. And that also leads into AI that's shipping, the assistant to help us write the queries for us and create those dashboards, and also the investigation does the first pass root cause analysis. We also get to choose the trade-offs. You're always going to have external data sources out there, whether it be from your cloud provider, Cloudflare, Databricks for business metrics, but we get to choose if we want to ingest this or if we simply want to query this. Cool. So every great telemetry story kind of starts with OpenTelemetry, and so did ours. OpenTelemetry really did provide the exit ramp. It really does decouple how you instrument code from where you actually end up sending it. But also, more importantly, it provides a shared protocol for all your different type of applications: .NET apps, Rust apps, Go apps, whatever it might be. At the end of the day, OpenTelemetry really is a protocol. This was super important to us because it allowed our telemetry to break free from our vendor. And that was super important for us. As I mentioned, we're a .NET shop, all hosted on Azure. Application Insights SDK was baked into every single one of these services. This meant that any tool change required us to re-instrument everything. So how do we do this? Well, we were already on the journey, and we were taking a manual instrumentation approach. However, we needed to move quickly, and we needed to move efficiently. But at the same time, we wanted to provide some instrumentation consistency between applications. And we decided to do this via an OpenTelemetry or an OTel defaults package. And I'm not going to say this is like a recommended approach. This is the approach that worked for us as an org. Delivery teams were able to write this single line of code, and we had variants for this between ASP.NET Core apps, isolated in-proc function apps. But what they got for free was traces, metrics, and logs all exported. They got runtime, HTTP, and process metrics all instrumented, and it was also dual export ready, which I'll touch a little bit on that later on. I would highly recommend everyone take a manual instrumentation approach when doing this, because remember, to be observable also means to be intentful. True observability means that you are instrumenting with intent and you're instrumenting with purpose. If you don't have time to do this via the manual approach, that's fine. Auto instrumentation is readily available. If you're running Kubernetes clusters as well, just use the OTel operator, provides a very good foundation. But also take this time, if you are going down the manual approach, to review your telemetry. Remember, telemetry can never remain static. It needs to be iterated on as your source code changes. Telemetry that you wrote 5 years ago is probably not relevant today. So we also injected attributes at the deploy stage as well. Standards often or not fail if you just write them up in a wiki page. I'm sure everyone has those wiki graveyards lying around. So if you can inject things and enforce them, highly recommend doing that. See here, we've got OTel service name. We've got a service namespace as well. Now this relates back to our system name, our Backstage catalog, or service catalog. We've got service version, deployment environment, and our instance IDs as well. Super critical for consistencies. A team cannot ship telemetry without a good labeling strategy. This is what, a team can also not ship telemetry that isn't attributed to a service, a system, or a version. This is what makes having dashboards, alerts, and cost attribution come for free and come automatic. Your attribution strategy might also differ depending on your hosting type. For example, if you're running Kubernetes clusters, you might want to enrich your telemetry for both app and infra with those kube attributes. This is what provides a good user experience, and when you provide that linkage between your application telemetry and your infrastructure telemetry, especially if you're using a tool such as Grafana. So, the migration strategy. How do you migrate between one vendor to another without a flag day or a D day? You still need to set a deadline, but you don't need to set a hard cutover period. You can provide an overlapping period, provide a graceful rollout period for your delivery teams. And this is what we did with that dual export approach. So you can see here we have a single service running that OTel package, and all of our services were pushing telemetry to both application insights and also the Grafana Cloud. This allowed teams to upskill and build at their own pace. The last thing that you want is teams waking up in the middle of the night, triaging an incident on a tool that they do not know how to use. It also provides teams to do a comparison between the old tooling and the new tooling as well. They can review and make adjustments if they need. So I want to touch a little bit on the collector and the collector layer as well. Highly recommend everyone implements the OpenTelemetry collector. We originally didn't have the OTel collector when we were pushing data to App Insights, and we found a little bit of issues not being able to control these pieces of telemetry there. The collector allows you to have full control of your telemetry. And actually at this stage is where we're enriching those pieces of telemetry with the Cube attributes. It also provides a separation of concerns from the application and the processing of the telemetry. So all your processing for enriching, transformation, sampling can all be hosted in the collector itself. Now we also did this with fleet management. Fleet management just provided us with a very strong user experience for that centralized navigation. We could see all of our pipelines, our connectors, config load statuses happening in real time, component health, and any config errors as well. Hot tip as well, if you are using adaptive telemetry and you have the collector set up, take the rules from adaptive telemetry and implement them into your collector, because you will also save on your egress costs as well. So how did we scale the collector? Well, more importantly, how did we scale the Alloy receiver? So we did a few ADRs on this. We thought we were going to have a receiver per team, per deployment. But we decided we'll start off real simple, okay? A single instance of the Alloy receiver, and it worked great. One Alloy receiver daemon set running, single endpoint, all apps were being ingested via that single cluster, the single collector. It worked really well until we started to run into a config management problem, when we had multiple teams wanting to make updates to the collector at the collector layer. Now we realized we needed to scale the config. Instances themselves were fine, but how were we going to scale this config, or the config management? So we did this by implementing a separation of concerns. So us as the infrastructure team would own the shared receiver pipelines and the shared exporter pipelines. And as I mentioned before, we use service namespace as a labeling strategy so that individual teams could manage their own service namespaces for their own ownership. With this config, because we were also going on a GitOps journey as well, this allowed teams to also have the config live alongside of their application. So you can kind of see where I'm going here with this by enabling teams and empowering them to become fully autonomous. As their source codes change, they can also make updates to the collector layer as well if they need be. So what have we achieved so far as an org? We've achieved a fair bit. We've done our application telemetry, metrics, logs, traces, profiles. We've done our cloud metrics, all ingested. We've done our Kubernetes monitoring. We've also done our cost and attribution. At the end of the day, we want one platform that can answer 3 questions. What went wrong, why, and what did it cost? Speaking of cost, we have also estimated a 35% reduction in observability spend as well. Mind you, this is a conservative number. I think it's more around that 45% mark, but we always give ourselves a 10% buffer. But more importantly, what we got was a mindset flip or a mindset shift with the feature of adaptive telemetry, being able to provide us that transparent feedback. It allows us to either cut costs in areas that we don't need and either take those cost savings or reinvest them in areas that we do need. Developers were super concerned about the costing before they had even started to ingested telemetry into the new product. With the new tooling, we're actually encouraging developers to instrument the pieces of telemetry that they are unsure of the usefulness. Because again, you can just instrument it, check in a week. If you're using it, great, you found yourself another unknown. If you're not, then you can just drop it. So for us as an org, the hardest part wasn't about getting the data in. The technical side of things was actually the easiest part. The hardest part was the adoption phase. Culture change is hard. Complacency is a real thing, even with legacy tooling, especially if the tooling has been there for a couple of years. We weren't asking a single team to migrate over, or just a couple of teams. We're asking the entire org to do a complete migration. With this comes patience. It will take time. It will take effort. You will do sessions, you will do workshops, and you will likely have to repeat those same sessions and repeat those same workshops. Treat observability as a product. It has users, has onboarding, has docs, has golden paths. Make sure that you run it like a product and help allow teams treat observability as a feature of their own product. Cool. So how did we do this? Well, what we did was we instilled observability champions, okay? We had 1 champion per team, and these champions became our entry points or influence multipliers to all the rest of the delivery teams that we had. It's just human psychology as well that a team is probably more likely going to be influenced from an internal member than the external members. But with this, we did Grafana upskilling, alerting and dashboarding coaching, OTel training, documented golden paths. We also provided these champions with elevated permissions as well. We brought them along the journey with us. Champions scale the coaching and they make their adoption theirs. So one of the challenging parts for us was the alert migration, or rather operationalizing Grafana, getting it ready for that on-call state. So we took a similar approach to the OTel package that I just showed you, and we created a set of plug-and-play templates. We as the SRE team, obviously, majority of the time, you're the observability SMEs, so we managed a set of golden standard alerts or an alerting strategy, and we managed the complex queries in the back. And what the delivery teams were able to do was with a simple manifest file, input their service name, team name, the rules that they want, and the severity as well. Things like error rate, latency, crash looping, whatever it might be. Now, the purpose of this isn't to write alerts for your developers or for your delivery teams. That's not what you want to do. The purpose of this is to save time for the delivery teams to get onboarded, is to enable them with a smooth migration period. Provide them a foundation and a starting point for them to build up on. With this, we also took the same approach from our alerts also to our dashboarding as well. So again, we've taken a set of templates. We've got like a triage-style dashboard and a retro-style dashboard as well. With the retro dashboard, of course, we're looking at long-term trend analysis, trend patterns, overall system summary. You've got shading in there as well during your busiest periods. For us, it's weekends, so you can analyze these patterns. We took the same approach with these golden paths as we did with the alerts. However, this would have not been possible without a labeling strategy. Okay, this is because we had attribution consistent across all of our services, we could simply have one dashboard with just a whole set of filters in there, and they could filter by cluster, service namespace. All the delivery teams can take this template, implement it, scope it directly to their services, and then use it as a foundation for them to build on. Again, the whole idea of this is to provide a starting point for your delivery teams whilst they upskill and tune or refactor that at a later stage. Now, I've got a triaging dashboard over here as well. However, I do soon suspect that triaging dashboards might soon become obsolete, and rather than us looking at a dashboard like we traditionally have, we will just probably be having a conversation with the agent. Which leads us to our next topic, as AI, the newest adoption lever. Use AI as much as you can to your full advantage. It does the work for you. It can not only teach you, but it can also help you find what you've missed. The capability for the assistant to be able to turn plain language into the PromQL is very powerful. One of the biggest, not say challenges or I would say concerns we had was, if we migrate over to an observability platform, we're going to have to relearn the entire querying language. That has been taken away from you. That tax no longer exists. You can use skills to teach your teams or teach your delivery teams, something that we've been trialing out with as well. We've got skills to review dashboards and alerts, and provide recommendations based on the alerts that it's reviewing. There's a lot of resources out there for best standards and best practices. Allow the AI to look at those. And it can help you find what you're missing. Connect your MCP servers, or I'm sure you would have seen GCX being released at AI Week. Also connect it to the source code. Help it surface the telemetry and alerts that you lack. Help it find the unknown unknowns in your applications. So before I just mentioned about the querying tax, the triage tax is a lot worse, okay? There's always going to be a delay by the time your systems detect there's an issue, by the time you receive that alert, and by the time you get out of bed and look on your monitoring, or get onto your monitoring tools. That 20 minutes that you spent at 2 a.m. deciding where to even look, is it application, is it infrastructure, was it a recent deploy, jumping between the tools just to form one hypothesis. Use the assistant investigation to do the first pass for you. You can even automate this as well, so when you have a P1 alert that fires off, you You can have that automated for you, but do be cautious with that. Tokens is a scarce commodity. If you have a noisy alert, it will just burn through all of your usage. But back in the days, triaging was a dashboard that we learned to read. Yeah, it was a UI that we learned to read and navigate, look at spans, look at that waterfall view, and be able to draw the dots together. Instead now, I think it's becoming a conversation that you actually have with the agent itself. Dashboards will still remain there, but they will remain there as evidence. So, the callback. This is where we are now. We've got the Grafana Investigator running. It's walking through the telemetry, application infra, or any recent deploys. It's creating a cause hypothesis as well. At the end of the day, I'm not debugging my tools anymore. The investigations work great out of the box, but write rules, write skills, and have it fine-tuned to your service and to your system to provide that additional context. And at the end of the day now, you're never debugging alone. So what's next for us at PointsBet? Well, more signals, the same single pane of glass, and the same paved road. So we're looking into doing RUM, front-end monitoring, database observability, Grafana IRM as well from PagerDuty, and our business metrics data sources and our SLOs as well. So I'll wrap it up with this, that observability isn't just an ops afterthought that we should be bolting on after the page. It's a product feature that needs to be shipped with the code. Build a platform that the teams love, and they'll do the rest. That is it.